The biggest question in science. You sit here staring at the night sky the same way countless generations before you have done. The stars seem endless, like glitter spilled across a black canvas. They make you feel small, yet connected to something vast. And then the thought sneaks in, what if this universe isn't the only one? What if beyond what you can see, there are other worlds, maybe infinite worlds, each one playing out a different version of reality? It sounds like science fiction. Hollywood has turned the word multiverse into a buzzword, plastering it on blockbuster posters, weaving it into stories where heroes step through portals to alternate Earths. But here's the myth busting truth: the multiverse isn't just a comic book fantasy. It's a real scientific question debated in laboratories, observatories, and universities around the globe. Some of the brightest minds alive believe it could explain why you exist at all. Others argue it's nothing but smoke and mirrors, an idea that will never be proven. And you're caught in the middle, standing on the edge of one of the deepest mysteries science has ever faced. You might think the question is simple: is the multiverse real or fake? But like most of science's greatest puzzles, the answer isn't black and white. To understand, you have to travel through layers of history, physics, and philosophy. You have to confront ideas that twist your imagination into knots. And most of all, you have to open yourself to the possibility that the universe you know, this one with its galaxies, planets, and life, isn't the only show in town. So let's begin by facing the first shocking twist. You already live inside something stranger than fiction. Think about it. Your universe burst into existence out of nothing, or at least out of something so unfamiliar it might as well be nothing. It expanded faster than the speed of light in its first moments. It cooled just enough to allow atoms, stars, and galaxies to form. And against all odds, it ended up with the right balance of forces: gravity, electromagnetism, nuclear interactions that allowed life to emerge. It's almost too perfect, like the dials on a cosmic machine were tuned with precision. If just one constant were slightly different, stars wouldn't shine, water wouldn't flow, and you wouldn't be here to wonder about any of it. This perfection is where the multiverse begins to haunt the human imagination. Because one way to explain why the universe is so finely balanced is to suggest it isn't unique at all. Maybe countless universes exist, each with different rules, different physics, different outcomes. Most of them would be barren, lifeless voids. But one, just one, might look like yours. And you ended up here simply because you couldn't exist anywhere else. That explanation is called the anthropic principle, and it rattles you because it sounds both profound and unsatisfying. It tells you that your existence isn't special, it's just a cosmic lottery ticket. You won because you're in the right universe, but there could be billions where you never even had a chance. But hold on. Before you buy into that, you need to step back. Because here's the twist most people forget: the multiverse has never been seen, never been proven, never been touched by experiment. It lives in equations, in theoretical frameworks, in interpretations of physics. Critics say it's a dangerous distraction, an excuse to stop searching for deeper answers within this universe. They warn that the multiverse can't be tested, and if science can't be tested, it isn't science at all. And this is where you feel the tension building. On one side, the multiverse feels like an elegant solution to cosmic mysteries, a bold idea that could rewrite everything you know. On the other, it feels like standing on quicksand, chasing shadows you may never catch. But pause for a moment. Isn't that exactly what makes it irresistible? The best questions in human history always sat in that uneasy space between wonder and doubt. When Galileo first pointed his telescope to the heavens, people mocked him for imagining moons around Jupiter. When Einstein bent space and time with his equations, even other scientists shook their heads. Maybe, just maybe, the multiverse is another one of those wild ideas that feels impossible until it suddenly isn't. And here's where trend meets truth. Right now, The multiverse has spilled into pop culture, hijacked by Marvel movies and science fiction shows. People talk about it casually, like it's a playground where Spider Man swings through alternate lives. But that myth hides the real drama. Because if the multiverse exists, it doesn't just mean there are other Earths. It means reality itself is deeper, stranger, and possibly infinite. So you ask yourself, what would it mean if there were another you? Maybe one who made a different choice, lived a different life, or maybe even more chilling, a universe where Earth never formed, where the Milky Way doesn't exist, where the laws of physics themselves are alien. The multiverse isn't just a playground. It's a reminder that the story of existence might be bigger than you can comprehend. And yet the doubt lingers. What if all of this is smoke? What if, after all the equations and theories, you discover that the universe is all there is, one self-contained story with no sequels, no spin-offs? Would that make it less magical? Or would it make this one universe even more precious, the ultimate rare gem in the void? That's the question you carry forward now. Is the multiverse real or fake? The only way to answer is to peel back the layers of history, science, and imagination, to trace the idea from ancient myths to cutting-edge physics, to listen to believers and skeptics, dreamers and critics. Because this isn't just a question about physics, it's about meaning. It's about why you're here. And by the time you reach the end of this journey, you'll realize something important. Whether the multiverse is real or not, the act of searching for it tells you more about yourself than you ever expected. You take a deep breath and think about the world around you. Every detail, from the warmth of the sun on your skin to the rhythm of your heartbeat, depends on an invisible web of physics holding reality together. Gravity keeps your feet on the ground. Electromagnetism sparks the atoms in your body. The nuclear forces keep the stars burning, creating the very elements that make life possible. Now imagine shifting just one of those cosmic dials, turning gravity a little weaker, or making the electromagnetic force a touch stronger. Suddenly, the delicate balance unravels. Stars wouldn't form, or if they did, they'd burn too quickly for life to evolve. Chemistry would fail. Planets wouldn't coalesce. You wouldn't be here. This is what scientists call the fine-tuning problem. The universe doesn't just exist, it exists in a way that seems suspiciously tailored for life. You can almost picture a cosmic control room filled with knobs for every physical constant: the gravitational constant, the speed of light, the strength of the strong nuclear force. And somehow, every knob is set just right. That eerie precision has haunted thinkers for centuries. Is it an illusion, a coincidence, or a clue? When you look at it closely, the numbers feel almost too neat. Take the cosmological constant, a tiny number that determines how fast the universe expands. If it were just a fraction larger, galaxies wouldn't hold together. If it were smaller, the universe might have collapsed in on itself long ago. Yet here you are, in a universe with just the right expansion rate, watching galaxies spiral across the sky. Or consider the balance between protons and neutrons in the early universe. If their masses were even slightly different, atoms wouldn't form the way they do. No atoms means no chemistry. No chemistry means no life. The whole story ends before it begins. You can't help but ask, why? Why is everything lined up so perfectly? Why do the equations of physics produce a universe that feels as if it was made for you to exist? Some see the hand of design in this, the work of a creator setting the rules. Others argue it's simply luck. Out of all the possible ways the universe could have been, it just happened to land on this one. But there's a third possibility, and it's the one that leads directly to the multiverse. What if the universe isn't unique? What if countless universes exist, each with their own settings on those cosmic dials? In most of them, the values are wrong. Stars never ignite. Life never sparks. They're vast stretches of nothingness, silent and empty. But in one universe, yours, the dials are set just right. And because you could only exist in that one, you find yourself here, looking back at the mystery and wondering how you got so lucky. That idea is what fuels the anthropic principle. It doesn't say the universe was designed for life, it says life appears only in universes where the conditions happen to allow it. In other words, you're here not because the universe is perfect, but because you couldn't possibly exist anywhere else. It's an explanation, but it feels cold. You almost recoil from it because it takes away the specialness, the sense of destiny, the idea that maybe the universe is tuned for you. Instead, it reduces everything to statistics. If there are infinite universes, then it's inevitable that one would look like this. Your existence becomes a matter of chance, not purpose. And yet, you can't ignore how compelling it is. After all, coincidences on this scale feel improbable. You don't stumble into a perfectly tuned piano by accident. You don't walk into a desert and find a watch ticking away without wondering who made it. And yet the universe is infinitely more complex, infinitely more balanced, and it runs without fail. The fine-tuning argument is one of the most powerful reasons scientists even take the multiverse seriously. It shifts the burden of explanation. Instead of asking, why is this universe perfect? The question becomes, if many universes exist, wouldn't it be natural that at least one of them looks like this? But before you jump fully into the multiverse, you should pause, because there's another way to look at it, one that doesn't require infinite copies of reality. Maybe the universe only feels fine-tuned because you're inside it, looking out. Think of it like sitting at a perfectly fitted chair. It seems designed for you, but maybe you're simply noticing it because you happen to fit. In other words, you're not the reason the universe is balanced. You're the byproduct of its balance. This paradox, the strange, almost eerie harmony of the cosmos, is where the multiverse debate gains its power. To many, it's impossible to look at the equations, the constants, and the coincidences without imagining a grander structure beyond what you can see. And to others, it's nothing more than a mirage, a trick of perspective. But here's where the emotional hook catches you. Imagine for a moment if the universe hadn't been tuned this way. If gravity were weaker, you'd never have felt the pull of the earth under your feet. If stars didn't form, you'd never have seen the night sky. If chemistry didn't work, you'd never have tasted food, never felt love, never even existed. Everything you are, every memory, every heartbeat depends on those cosmic dials being set just so. That realization makes you shiver, because whether the multiverse is real or fake, one fact is undeniable. You live in a universe that seems impossibly perfect. And that perfection is what pulls you deeper into the mystery, into the possibility that your world is just one drop in an infinite sea. So the question sharpens. Is the perfection proof of something greater? God, fate, or infinite worlds? Or is it just a beautiful accident, a fragile coincidence that somehow, impossibly, turned into life? The universe doesn't answer. It only waits for you to keep searching. You might think the multiverse is a modern idea, born from particle accelerators and cosmic equations. But if you listen closely, you'll hear echoes of it in humanity's oldest stories. Long before telescopes and quantum mechanics, people looked up at the night sky and wondered, is this the only world? Or could there be others? You can almost picture it. A fire crackling in the dark, smoke rising to the stars, and a storyteller leaning forward, weaving tales of many worlds. For ancient cultures, the universe wasn't a sterile machine. It was alive, layered, full of unseen realms. And though they didn't call it a multiverse, the seed of the idea was already there. Take the ancient Greeks. Philosophers like Anaximander and Democritus speculated that other worlds might exist beyond ours. Democritus, often called the father of atomic theory, suggested that infinite atoms moving in the void could combine to form not just one cosmos, but many. Each one could have its own order, its own suns, its own creatures. For him, our universe was not unique. It was one among countless others, scattered like islands across an endless sea. Or look east to Hindu cosmology. Ancient Hindu texts describe a cycle of creation and destruction that repeats endlessly. The universe isn't singular or permanent, it's one of countless universes, born and dissolved like bubbles on the surface of an ocean. Some texts even say these universes float together, each with its own gods, its own rules, its own destinies. To you, that might sound eerily similar to the bubble universe idea that modern physics proposes thousands of years later. Then there are the Norse myths, where Yggdrasil, the great world tree, connects multiple realms. Asgard, Midgard, Helheim, each a separate world, yet linked by the same cosmic trunk. To the Norse, reality was never just one flat stage. It was layered, branching, infinite in possibility. Even in Mesoamerican traditions, you find the same pattern. The Maya spoke of multiple layers of heaven and underworld, each with its own gods and trials. The Aztecs believed in cycles of suns where worlds rose and fell in succession. One world ends, another begins. Sound familiar? It's the rhythm of the multiverse, written not in equations, but in myth. When you see this pattern, you realize something important. The human imagination has always resisted the idea of a single isolated universe. From campfire myths to sacred texts, we've carried the instinct that there must be more, that reality is too vast to be confined to one stage. It's almost as if the multiverse is a story humanity was destined to tell, long before we had the language of science to describe it. But here's the myth-busting twist. For most of history, these weren't scientific theories. They were metaphors, spiritual frameworks, ways to make sense of life and death. The many worlds of myth weren't parallel universes in the physics sense. They were moral landscapes, places where gods battled, souls traveled, or cycles repeated. Still, the resonance is undeniable. When you hear about Hindu cycles of universes or Greek philosophers speaking of infinite worlds, you can't help but feel a shiver. How could people thousands of years ago, with no telescopes, no satellites, no quantum mechanics, dream of something so similar to what scientists debate today? Was it coincidence, poetic imagination, or a glimpse of something deeper? Here's where the emotional pull tightens. Imagine being an ancient thinker, standing under the night sky, knowing almost nothing about the stars above. You don't see galaxies or cosmic microwave backgrounds. You only see points of light. And yet your mind leaps to infinity. You ask yourself, surely this cannot be all. Surely there must be other worlds, other skies, other stories. That instinct is still inside you. Even now, with science explaining so much, you look up and feel the same tug. You sense that the universe you see can't possibly be the whole picture. The multiverse isn't just a theory, it's a continuation of that ancient human longing for more. But here's where the modern twist comes in. The ancients used myth to fill the gaps. You have equations. They had Yggdrasil, you have string theory, they had the cycle of suns, you have cosmic inflation. The language changes, but the hunger stays the same. And maybe that hunger says something about you. Maybe it reveals that humans are wired to imagine beyond the visible, to stretch past the horizon. The multiverse isn't just physics, it's psychology, it's spirituality, it's imagination reaching for the infinite. Still, as inspiring as these myths are, they remind you of a sharp boundary. Because while ancient stories whispered of many worlds, modern science demands more. It doesn't settle for metaphor. It wants evidence, equations, predictions. And that's where the real story of the multiverse begins, not at the campfire, but in the laboratory when cosmology itself is born, is bum. So you leave the ancient storytellers behind, grateful for the seeds they planted, and you step forward into the dawn of modern science. The myths fade, the fire dies down, and in its place rises a new flame, the Big Bang, the cosmic birth cry that will set the stage for everything you're about to discover. You've walked through the myths and ancient guesses, but now you stand at the threshold of something new. The campfires fade, the gods and world trees retreat into memory, and humanity enters an age of telescopes, equations, and experiments. This is where cosmology is born, and with it, the first scientific steps toward the multiverse. It begins in the early 20th century when astronomers looked deeper into the sky and realized that the universe is stranger and larger than anyone imagined. Until then, many believed the Milky Way was the entire cosmos, a single island of stars surrounded by endless dark. But in 1924, Edwin Hubble, using the Hooker telescope at Mount Wilson, discovers that fuzzy patches of light in the night sky aren't clouds of gas. They're entire galaxies, each one filled with billions of stars, scattered across unimaginable distances. Suddenly, the universe explodes in scale. You thought you lived in a vast cosmos, but in truth, you were only staring at one grain of sand on an endless beach. Then comes the next shock. In 1929, Hubble studies those galaxies and notices something astonishing. Their light is shifted toward the red end of the spectrum. It means they're moving away from us. Not just one or two, almost all of them. The universe isn't static, it's expanding. This realization rocks science to its core. For centuries, philosophers and scientists assumed the cosmos was eternal, unchanging, steady. But Hubble's discovery tells you that everything is rushing outward, as if the universe itself is stretching. And if it's expanding now, then it must have been smaller in the past. Trace it backward far enough, and you arrive at a beginning, a moment when the universe burst into existence from something unimaginably dense and hot. That moment becomes known as the Big Bang. It's hard to overstate how revolutionary this idea is. Suddenly, the universe has a history. It has a birth. It isn't eternal after all. It had a fiery start, a moment of creation. And with that revelation, 1,000 new questions ignite. What caused the Big Bang? What existed before it? Could there have been other bangs, other beginnings, other universes? For the first time, the seeds of the multiverse move from myth into physics. But the Big Bang alone doesn't demand a multiverse. It explains how this universe began, not whether others exist. To get to the multiverse, you need another leap, one that comes decades later from the theory of cosmic inflation. In the 1980s, physicist Alan Guth and others proposed that in the earliest sliver of time after the Big Bang, the universe underwent a mind-bending growth spurt. In less than a fraction of a second, it expanded faster than the speed of light, ballooning from subatomic size to something vast. This inflation smooths out the wrinkles of the cosmos and explains why the universe looks uniform no matter where you look. But inflation carries a shocking implication. If it happened once, why couldn't it happen again and again, endlessly? Imagine a field of energy bubbling, creating pocket after pocket of expanding space. Each pocket could be its own universe, sealed off from the others, each with different laws of physics. You live in one bubble, but beyond it, an infinite foam of universes might stretch forever. And just like that, you see how the multiverse sneaks in, not as myth, but as a consequence of equations written on chalkboards. Inflation doesn't just solve problems with the Big Bang. It opens the door to countless other worlds. Of course, the skeptics push back. They remind you that inflation, while elegant, is still a theory. It explains much, but it also creates questions it can't yet answer. And when you add the multiverse on top of it, the line between science and speculation begins to blur. Can you ever test something beyond your universe? Or are you chasing shadows? But pause for a moment. Think about how radical the journey has already been. A century ago, you didn't even know other galaxies existed. Now you're staring into a cosmos that had a fiery birth, that expands without end, and that might be just one bubble in an infinite ocean. It humbles you. It also excites you, because science doesn't just replace myth. It creates new wonder, new mystery. The gods and world trees may have vanished, but what's left is no less staggering. And so you stand here in the age of modern cosmology, staring at a universe with a beginning, an expansion, and perhaps siblings beyond your sight. The question of the multiverse is no longer just philosophy, it's physics. And if physics can lead you this far, into a cosmos born from fire and inflated to infinity, what else might it reveal? You thought the universe was already strange, with galaxies rushing apart and cosmic bubbles inflating faster than light, but nothing prepares you for the world of the very small, the quantum realm. Here, reality itself behaves like a magician, pulling off tricks that defy your common sense. And it's here, in this microscopic chaos, that one of the most daring versions of the multiverse is born. Imagine peering into the subatomic world. Electrons, protons, photons, particles smaller than you can picture, refuse to behave like tiny billiard balls. Instead, they exist as waves of probability. An electron isn't in one spot. It's in many possible spots at once, described by something called a wave function. Only when you measure it, when you look, does it collapse into a single outcome. This is quantum mechanics, and it's not just theory. It's been tested and confirmed countless times. Without it, your phone wouldn't work, your GPS would fail, and your computer chips wouldn't exist. Yet, despite its success, it leaves you with a riddle. What does it mean that particles exist in many states until you measure them? For decades, scientists debated this puzzle. Some argued that collapse is real, that observation forces reality to choose. Others said the wave function is just a mathematical trick. But in 1957, a young physicist named Hugh Everett proposed something radical. What if the wave function never collapses at all? What if every possible outcome actually happens, but in different universes? This is the many worlds interpretation. Picture it. You flip a coin. In your universe, it lands heads, but in another, it lands tails. Both outcomes are real, both play out fully, but you only experience one branch. Every time a quantum event occurs, reality splits, branching like an endless tree. In one world, you take the job, in another, you don't. In one, you say yes, in another, you say no. Each possibility is written into existence, spawning new universes with every choice, every particle interaction, every heartbeat. It sounds insane, but Everett believed it solved the riddle. No collapse, no mystery, just infinite branching universes, all equally real. And here's the emotional twist. If many worlds is true, then there are versions of you scattered across reality. Some live lives almost identical to yours. Others diverge wildly, shaped by a single decision. Somewhere, there's a you who never moved from your hometown, a you who became a painter, a you who never met the people who define your world today. It's thrilling. It's also terrifying, because it suggests that your choices matter less than you think. Every path is taken. Every outcome exists. The universe doesn't choose, it multiplies. Of course, the critics are sharp. They say many worlds is untestable, unprovable, and unnecessary. They argue it multiplies entities beyond reason, creating infinite universes just to explain a coin flip. And yet, others defend it passionately. They point out that it's consistent with the math, that it avoids the mystery of collapse, that it treats the equations of quantum mechanics as brutally literal. And here's where you feel the tension again. You're caught between disbelief and awe. On one hand, the idea that new universes split off every moment feels absurd. On the other, the math whispers that it's possible, and science has taught you not to dismiss the absurd too quickly. But step back for a moment. Whether or not many worlds is true, quantum mechanics itself already hints that reality is stranger than anything you experience day to day. Particles tunnel through barriers they shouldn't cross. Cats in Schrödinger's thought experiment are alive and dead at the same time, until observed. Reality at its core is smeared, probabilistic, slippery. So is it really so far-fetched to imagine that the weirdness doesn't stop at particles? That it might ripple outward, creating entire universes? Think about what that means for your life. Every time you make a choice, you feel the weight of it, the possibility that you could have chosen differently. Regret, nostalgia, what ifs. The many worlds interpretation doesn't erase those feelings, but it reframes them. Somewhere in another branch, you did choose differently. You lived the what if. Those alternate paths aren't just imagination, they're reality. But here's the haunting question. If those other versions of you exist, are they truly you? Or are they strangers, sharing only a beginning before diverging into lives you can never touch? Quantum mechanics doesn't answer that. It doesn't tell you whether to feel comfort or despair. It only forces you to admit that reality is far less solid than it seems. And so, as you step out of the quantum world, you carry a new vision of the multiverse. Not just cosmic bubbles expanding in the void, but endless branches of possibility written into the fabric of every particle, every decision. A multiverse not of galaxies, but of choices. And you can't help but wonder, which is stranger? Infinite universes born from cosmic inflation, or infinite versions of you created by quantum chance? The universe stays silent, but the question lingers, and it pushes you forward, deeper into the mystery, toward the next layer of the multiverse. You've just stepped out of the quantum world, dizzy with the thought of infinite versions of yourself. But the multiverse doesn't only hide in the tiny probabilistic realm of particles, it also stretches across the largest canvas imaginable, the very fabric of space itself. And to understand it, you have to return to the early universe, back to the moment just after the Big Bang. You already know that the universe is expanding. Galaxies are racing apart, carried by the stretching of space. But what you may not realize is that in the first sliver of a second after the Big Bang, something even stranger happened. The universe didn't just expand, it exploded in size at a speed that makes your imagination collapse. This event is called cosmic inflation. Inflation theory, first proposed by Alan Guth in 1980 and refined by others like Andre Linde, suggests that right after its birth, the universe doubled in size again and again in an unimaginably short time. In less than a heartbeat, it grew from smaller than an atom to something vast. That expansion smoothed out the cosmos, explaining why the universe looks so uniform no matter where you look. It's the reason the cosmic microwave background, the faint afterglow of the Big Bang, is so eerily even. But here's the twist. Inflation may not be a one-time event. According to some models, inflation could be eternal. Imagine space as a vast field bubbling with energy. In one region, inflation stops, and a universe like ours forms. But around it, inflation continues, stretching space further, creating new bubbles. Each bubble pops into existence as its own universe, sealed off from the others by expanding space. This is the multiverse of eternal inflation. Picture it. Our universe is just one bubble in a cosmic foam floating alongside countless others. Each bubble might have its own laws of physics, its own constants, even its own dimensions of space and time. Some could be lifeless voids, others could be strange beyond comprehension, worlds where gravity is crushingly strong or where stars never form. And somewhere in this endless froth, one bubble looks like ours, balanced just right for galaxies, planets, and life. You feel the emotional weight of it. The night sky, which once seemed infinite, now feels small. All those galaxies, hundreds of billions of them, are still just part of one bubble. Beyond that, an ocean of universes hidden forever from your sight. But here's the haunting part. You can never cross from one bubble to another. They're separated by inflating space, expanding faster than light. No spaceship, no telescope, no experiment could ever bridge the gap. If the multiverse exists, you are forever trapped inside your own bubble, able only to imagine what lies beyond. And yet hints may still be hiding at the edges of your universe. Some scientists suggest that if bubbles collided in the early moments, their scars might linger in the cosmic microwave background, subtle patterns imprinted on the sky. Teams have searched for these signals, cold spots, anomalies, but so far the evidence is thin, ambiguous, debated. Still, the possibility lingers like a whisper. Maybe your universe once brushed against another. Critics call this dangerous speculation. They argue that if bubble universes can never be observed, then eternal inflation is philosophy, not science. They warn that cosmology risks drifting into untestable territory, but supporters reply that the theory naturally emerges from equations that already explain so much. Inflation accounts for the universe's uniformity, its flatness, its structure. If the math also points to bubble universes, shouldn't you take that seriously? And here's the myth-busting truth. The multiverse of eternal inflation isn't a wild add-on. It's a natural consequence of the physics many cosmologists already accept. You don't have to believe in magic portals or comic book fantasies. You just have to follow the equations to their logical end. Still, logic doesn't make the idea less dizzying. Imagine standing at the edge of the ocean, staring at endless waves stretching to the horizon. Now imagine that every wave is a universe, rolling into existence, infinite in number. That's the picture eternal inflation paints. And somewhere among them, this fragile bubble, your bubble, is where you live, love, breathe, and wonder. You can't help but feel small, but you also feel awe, because if eternal inflation is true, then reality is bigger than your wildest dreams. It means the cosmos isn't just vast, it's boundless. It means your universe isn't the whole story. It's a single page in an infinite library, and the library is still being written. You've drifted through bubbles of eternal inflation, picturing the universe as one frothy drop in an infinite ocean. But there's another frontier waiting for you, one that doesn't just multiply universes, it multiplies the very laws of nature. And to reach it, you need to follow the most daring framework in modern physics: string theory. At first glance, string theory sounds almost poetic. Instead of tiny particles being the fundamental building blocks of reality, string theory says the universe is made of unimaginably small, vibrating strings of energy. Each vibration gives rise to what you see as particles: electrons, quarks, photons. Like different notes played on the same violin string, different vibrations produce different forces and matter. It's elegant, beautiful, almost musical. But string theory carries a shocking price. For it to work, the universe can't just have the 3 dimensions of space and one of time you experience. It needs more. 10 dimensions, or even 11, curled up so tightly you'll never see them directly. Hidden dimensions, folded into reality like secret compartments. And here's where the story tilts toward the multiverse. Because when physicists explore the mathematics of string theory, they find not one possible universe, but a staggering number of them. The equations don't lead to a single solution. They lead to an entire landscape of possible realities, each with different shapes of curled up dimensions, different physical constants, different rules. How many? Some estimates say as many as 10^500 possible universes. That's a number so large you can't truly imagine it. More universes than there are atoms in all the stars of all the galaxies you can see. A cosmic menu of possibilities, each one a different universe, each one just as mathematically valid as your own. It feels overwhelming. You thought your universe was unique. Now it's one of half a Googleplex of possibilities. You're standing in a cosmic showroom filled with universes, each with its own design, its own physics, its own destiny. And here's the emotional twist. This landscape may not be just abstract math. It could be real. Eternal inflation could act like a cosmic generator, spawning bubble after bubble, each one landing on a different solution from the string landscape. The result? A multiverse where every possible version of physics plays out somewhere. A multiverse so vast that the fine-tuning of your universe isn't surprising at all. Out of tens to 500 options, of course, one would allow life. And that's the one you're in. It almost sounds too neat, doesn't it? The string landscape seems to explain the fine-tuning problem effortlessly. But at the same time, it raises an uncomfortable question. If there are 10 to the 500 universes, how could you ever prove you live in just one of them? How could you ever test the others? Critics argue that this isn't science anymore. It's surrender. It's saying anything is possible, so we can't explain why we live here. And yet, the defenders of string theory remind you that it's more than speculation. It's attempt to unify everything gravity, quantum mechanics, the forces of nature into one framework. And in doing so, it stumbled into the multiverse almost accidentally. The landscape wasn't invented to sell comic books. It's a consequence of trying to build a theory of everything. You feel the weight of that because it means the multiverse isn't just a dreamer's fantasy. It's a serious side effect of humanity's most ambitious attempt to understand reality at its deepest level. Still, doubt lingers. You wonder if the landscape is too big, too messy, if science stretches too far, chasing universes you'll never see. But then you remember something important. Even if you can't see the other universes, the theory that predicts them might still leave fingerprints in your own. Subtle patterns in particle physics, clues in the cosmic background. Maybe one day experiments will narrow the landscape, pointing to the truth. For now, the landscape remains both inspiring and frustrating. It opens your imagination to infinite possibilities while leaving you grounded in the one universe you can touch. It's like staring at a mountain range in the distance. It's majestic, endless, but just out of reach. And so you carry this new vision forward. The multiverse isn't only about quantum branches or bubble universes. It's also about an infinite mathematical terrain where each valley is a universe, each peak a different version of reality, and you are walking just one path among them. But if the string landscape is real, then there could be versions of existence so alien you can barely conceive them. Worlds without stars, worlds without atoms, worlds with dimensions twisted in ways your brain can't even picture. It makes your universe feel fragile, precious. Because out of 10 to 500 possibilities, this is the one where you are alive, breathing, and wondering. And maybe that's the strangest truth of all. The many worlds mystery. Up until now, the multiverse has felt distant, vast cosmic bubbles, invisible string landscapes, universes locked beyond your reach. But now the idea turns inward. Because there's a version of the multiverse that doesn't just multiply space and physics, it multiplies you. You remember quantum mechanics, the strange world of uncertainty where particles exist in many states at once. One interpretation of this strangeness is called the many worlds interpretation. First proposed by Hugh Everett in the 1950s, it makes a bold claim. Whenever a quantum event can go one way or another, the universe doesn't choose, it splits. Both outcomes happen, each in its own branch of reality. Think about what that means. Every coin flip, every roll of dice, every decision creates two paths. In one, you turned left, in another, you turned right. In one, you stayed silent, in another, you spoke up. The result is an ever-branching tree of universes, each holding a different version of you, living a different life. You pause and feel the chill of it. Right now, in some parallel universe, there's a version of you who took a different job, who married someone else, who never met the people you know. Somewhere out there, another you never survived that accident. Another you is a billionaire. Another you is still a child. Every possibility exists, playing out endlessly. At first, it sounds like science fiction, an infinite hall of mirrors. But the shocking part is that it emerges directly from the equations of quantum mechanics. The math doesn't require wave function collapse. It doesn't need randomness. Instead, it simply allows every possibility to unfold. If you take the equations seriously, then many worlds is a natural conclusion. And suddenly the multiverse feels intimate, no longer just abstract bubbles or strings, but personal echoes of your own choices. You begin to wonder, if all those versions of you exist, are they truly separate? Or do they haunt you in subtle ways, hidden beneath the surface of your life? Pop culture loves to play with this idea. Movies imagine heroes meeting their alternate selves, stepping into lives they never lived. But reality isn't so forgiving. If many worlds is true, those parallel lives are forever cut off. You'll never know them. You'll never speak to the other yous. You'll only live this path while the others slip away into unseen branches. Still, the emotional weight lingers, because the thought of infinite versions of yourself raises unsettling questions. Are you really unique, or just one among countless copies? Does your life matter less, knowing every possibility is realized somewhere else? But here's the myth busting truth. Even if infinite versions of you exist, this version, the one experiencing these words, is still singular. The others may be real in their own branches, but they don't erase your choices, your meaning. They only remind you of how fragile and precious each moment is. Scientists argue over many worlds fiercely. Some call it elegant, removing randomness from quantum mechanics. Others call it absurd, multiplying realities without proof. But the debate itself reveals something important. The multiverse isn't just about physics. It's about identity, about existence, about what it means to be you. And maybe that's why it unsettles you so deeply, because cosmic bubbles and string landscapes are vast, impersonal. But many worlds forces you to look in the mirror. It whispers that the life you're living is one thread among infinite others, and yet somehow it's still yours alone. You sit with that thought, feeling both small and infinite at the same time. Every path you didn't take is still out there, echoing in the branches of the multiverse. And in some quiet way, that knowledge makes you cherish the path you're on, because this version of you in this universe is the only one you'll ever truly know. Why proving or disproving the multiverse is nearly impossible. The observational limits. You've traveled far into the story of the multiverse, through myths, through mathematics, through cosmic theories that stretch your imagination to its breaking point. But now you hit the wall, the sharp edge of reality that scientists themselves keep colliding with. The problem is not just that the multiverse is strange. The problem is that it may be forever beyond proof. Think of it this way. You live inside a bubble. The bubble is your universe, the place where galaxies swirl, stars are born, and life finds a foothold. This bubble is enormous, so enormous that you can barely see a fraction of it, but still it has a boundary. Light has a speed limit. The universe has an age. Put the two together and you get a horizon, a cosmic border past which no information can ever reach you. It doesn't matter how powerful your telescope is. It doesn't matter how many satellites we launch into orbit or how long we wait. There will always be regions of the universe forever cut off from us. And if there are other universes beyond that horizon, well, by definition, they are outside our reach. You could point the most advanced telescope straight at the edge of the sky, and you would still see nothing but darkness. This is the core of the evidence problem. The multiverse may exist, or it may not. But in both cases, it sits outside the boundaries of what observation can touch. You are left trying to measure something that hides behind the very laws of physics you rely on to measure anything at all. Some scientists try to be clever. They argue that if other universes bump against ours, the collision might leave a scar, like a bruise in the fabric of the cosmic microwave background, the faint afterglow of the Big Bang. Astronomers have scanned the sky, hunting for strange circles, cold spots, or ripples that might whisper of a cosmic neighbor brushing against us. But so far, the evidence is blurry, inconclusive, frustrating. The scars you think you see might just be noise or random chance or an artifact of your instruments. Others suggest that the multiverse is not directly testable, but indirectly unavoidable. If our current theories, cosmic inflation, string theory, quantum mechanics, are correct, then the multiverse might simply fall out of the equations. In other words, you don't prove the multiverse by spotting it. You prove the theories that predict it, and the multiverse comes along for the ride. But that, too, is slippery, because if those theories remain untested or incomplete, then the multiverse remains an elegant possibility. Nothing more. And here's the emotional twist. You might have to accept that some truths are locked away, hidden forever from human reach. We've grown up believing that science can solve every mystery if given enough time, enough data, enough ingenuity. But the multiverse pokes at the limits of that faith. What if reality contains layers we can never peel back? What if the biggest questions Are there other worlds? Are there other versions of you? Can never be answered with certainty. That realization stings. It feels unfair. You want the universe to be knowable, to give up its secrets if you just try hard enough. Instead, it throws you paradoxes and dead ends. It forces you to live with ambiguity. And yet, there's a strange beauty in that. Because even without proof, the multiverse pushes you to expand your imagination, to stretch your mind beyond the boundaries of what you can see. It reminds you that your perspective, no matter how wide, is always small compared to the totality of existence. That humility, knowing there are things you may never measure, can be its own kind of wisdom. But don't mistake humility for surrender. Scientists are nothing if not stubborn. They continue to invent new methods, new tools, new ways of asking the question. Could gravitational waves carry whispers from other universes? Could high-energy particle physics reveal cracks in our cosmic bubble? Could mathematics itself, refined and sharpened, give us answers when observation cannot? Every attempt is a gamble against impossibility. Every experiment is a reminder that you are playing chess against the universe, and the universe always has more moves than you can anticipate. But still, the effort continues, because even if proof remains out of reach, the search itself teaches us something vital about curiosity, persistence, and the human spirit. And so you sit with the paradox. The multiverse may be real, but unprovable. It may be fake, but unfalsifiable. Either way, the evidence problem hangs like a shadow. For the scientist, it's a technical challenge. For you, it's something deeper. It's the reminder that certainty is not guaranteed, that life is lived in the in-between, that mystery may never dissolve completely. So the next time you hear someone claim with confidence, the multiverse is real, or the multiverse is nonsense, remember the truth is quieter, messier, more humbling. We don't know. We may never know. And maybe, just maybe, that's exactly how it's supposed to be. Scientists who say multiverse theories aren't science at all, the unfalsifiable critique. You've heard the dazzling theories, the endless possibilities, the whispers of infinite versions of you scattered across parallel worlds. But before you let your imagination drift too far, you need to stop and face the resistance, because not everyone in science is on board with the multiverse. In fact, some of the most respected voices in physics and philosophy have called it dangerous, not because it's too wild, but because it might not be science at all. Here's the crux of their argument. A theory that cannot be tested is not science, it's speculation. You've already seen the evidence problem. The multiverse sits beyond observation, sealed away by the very rules of physics that define your universe. Critics seize on that. They argue that if you can't ever prove or disprove the existence of other universes, then the multiverse doesn't belong in physics. It belongs in metaphysics, or maybe even mythology. Sir Karl Popper, the philosopher who shaped much of how modern science defines itself, had one golden rule: a scientific theory must be falsifiable. That means there must be some possible observation, some experiment, that could prove the theory wrong. Without falsifiability, you don't have science. You have a story. Multiverse critics wield that rule like a sword. They say, if no conceivable experiment can disprove the multiverse, then calling it science stretches the word until it snaps. It's like claiming there are invisible dragons in your garage. You can never catch one, never measure one, never disprove their existence. But does that make them real? Even among scientists, this critique sparks fierce debate. Nobel laureate David Gross has argued that string theory, and by extension some versions of the multiverse, risks becoming non-science because it leans too heavily on elegance and mathematics without experimental anchors. Physicist George Ellis has warned that the multiverse could blur the line between physics and philosophy, weakening the very standards that keep science grounded. And then there's the emotional layer. You've grown up trusting science because it builds airplanes that fly, medicines that heal, and technologies that actually work. Science earns its credibility by being testable, by proving itself in the real world. But if scientists begin embracing theories that can never be tested, doesn't that betray the very spirit of science? Doesn't it feel like stepping into faith dressed in equations? The critics aren't saying imagination is bad. Far from it. They know science thrives on bold ideas. But they warn against confusing the beauty of a theory with its truth. Just because the multiverse feels profound, just because it makes sense within certain equations, doesn't mean it reflects reality. Nature is under no obligation to match human imagination. And here's the myth busting moment. Not all scientists who reject the multiverse are closed minded or stuck in old ways of thinking. Many of them are driven by caution, by a responsibility to protect the integrity of science itself. They worry that if you let untestable ideas dominate physics, you erode the very foundation that makes science trustworthy. But of course, there's a counterpoint. Supporters of the multiverse argue that critics are being too rigid. They say science evolves. Once upon a time, black holes were considered speculative, even unscientific. The same was said about atoms, germs, and the idea that Earth moves around the sun. Proof often comes later, sometimes centuries later, after technology catches up with imagination. Why should the multiverse be any different? So you find yourself caught between two forces: the dreamers who insist the multiverse is the natural outcome of modern physics, and the skeptics who say, show me the data or stop calling it science. And this tension tells you something important. The multiverse is not just a question about reality, it's a question about how we define science itself. Do we demand evidence now, or do we allow ideas to float in the space between imagination and experiment, waiting for the day when proof might arrive? You can feel the stakes here. It's not just about parallel universes, it's about trust. If science begins to sound like mythology, people may stop believing in it. And if that happens, the progress of human knowledge, the rockets, the cures, the discoveries, could falter. The multiverse, in this sense, becomes more than a theory. It becomes a test of science's own soul. So you sit again under the night sky, feeling the weight of the question. Are the critics right? Is the multiverse just a clever story, unfalsifiable and forever beyond reach? Or are they too cautious, too quick to dismiss what could one day become the next great leap in human understanding? For now, no answer satisfies both sides. And maybe that's the point. The multiverse is as much a mirror of human ambition as it is a scientific theory. Some see in it our boldness to dream, others see in it our weakness to believe in things we cannot prove. And you're left holding both truths, knowing that skepticism and imagination are not enemies, but partners in the long, unfinished story of science. By now, you've traveled deep into theories, equations, and debates. You've weighed evidence or the lack of it and listened to the skeptics warn against unfalsifiable ideas. But the multiverse is not only a scientific puzzle, it is an emotional one. You may not have realized it yet, but it pulls at something intimate inside you, something that goes beyond math or physics. Imagine for a moment that the multiverse is real. Somewhere beyond the cosmic horizon, other versions of you exist. In one world, you chose a different career, fell in love with someone else, lived a life you only dreamed of. Somewhere, another version of your childhood self laughed at a different joke, took a different road home, or never moved away from the city you left behind. Infinite possibilities, each one real somewhere, existing all at once. It is a thrilling thought, isn't it? It's the ultimate nostalgia. Every what if you've ever whispered to yourself, what if I had tried harder? What if I had stayed? Suddenly gains weight. You are not alone in your regrets, your triumphs, or your quiet joys. Somewhere they are all happening. Somewhere your life unfolds differently, yet equally vividly. And yet, that thrill carries a strange ache. If other versions of you exist, does your current life feel diminished? Are your choices less meaningful if somewhere else they were made differently? The multiverse stretches reality to such an extreme that it forces you to confront the paradox of significance. Your life, intimate and unique to you, is simultaneously ordinary in the vast cosmic library of possibilities. Now, imagine the opposite. Imagine the multiverse is a beautiful, comforting lie. There is only this universe, only this life. Every choice you've made is irrevocable. Every what if is confined to your memory, unplayed and unseen. That can feel terrifying, like standing on a cliff with no safety net. The weight of finality presses down. You are finite, your experiences unrepeatable, your mistakes permanent. And yet, there is a profound clarity in that truth. If this is the only universe, the only you, then every decision, every heartbeat, every fleeting moment becomes precious. The sun rises only once, the laughter of friends is finite, and the chance to love, to create, to explore is all the more extraordinary because it cannot be repeated in infinite other worlds. This finality can inspire gratitude, a fierce appreciation for the fragile, irreplaceable beauty of existence. This is why the multiverse resonates so deeply in art, in literature, in our culture. Stories of parallel worlds, of alternate lives, strike a chord not because they are scientifically proven, but because they echo a human longing. We wonder, we dream, we hope. We tell ourselves, maybe the life I missed is still happening somewhere. Maybe the version of me that took the risk, that spoke the words, that followed a different path, is alive in another reality. And in that longing, there is nostalgia, not just for the past, but for possibilities that never were. You can feel it in the quiet corners of your mind, in the small regrets and the unspoken wishes. The multiverse is not just a cosmic theory. It is a mirror, reflecting all the ways your life could have been different, and all the ways it is uniquely yours. Emotionally, the multiverse invites both wonder and melancholy. It is hope and despair at once. Hope because infinite possibilities suggest that nothing is truly lost. Despair because infinite possibilities suggest that meaning is diffuse, perhaps diluted across uncountable realities. It is a paradox that science rarely addresses directly, but it touches the deepest parts of human experience, and you feel it. When you look at the stars tonight, or when you hear a song that reminds you of a long ago day, you may sense that strange tug in your chest. That tug is the emotional multiverse. It whispers that your life is one thread in an incomprehensible tapestry, a fleeting moment in a story too vast to grasp. It reminds you that every choice matters, yet not in the way you imagined. Matter differently, matter infinitely. Even skeptics sense this pull. Many physicists who dismiss the multiverse as untestable admit its emotional power. They know it stirs our imagination, invites reflection, and ignites curiosity. It makes us consider our place in the cosmos and the fleeting beauty of our own existence. It reminds us to live fully because even if there are infinite worlds, this is the one you are in. And perhaps that is the true gift of the multiverse, whether it exists or not. It teaches empathy for yourself and for the lives you did not lead. It asks you to honor the one life you do have while acknowledging the infinite yous that could have been. It blends nostalgia and wonder, grief and hope into a lesson both quiet and profound, that life is fragile, fleeting, and astonishingly precious. So you pause, letting the weight of the stars sink in. You think about choices, regrets, and dreams. You feel a surge of gratitude and longing at the same time. And somewhere in that complex tangle of thought, you realize that the multiverse, whether fact or fantasy, does exactly what great stories do. It makes you pause, it makes you reflect, it makes you feel. Because at the end of the day, the multiverse is more than physics. It is a mirror to your soul. It is a measure of your hopes, your fears, your endless curiosity. It is a reminder that no matter how small you feel under the night sky, your life, your choices, your story matters, perhaps in ways that even the universe cannot fully contain. How movies, Marvel, and media use the multiverse idea and how it shapes public imagination. You've stared at the night sky, contemplated cosmic inflation, and felt the weight of infinite possibilities tug at your heart. But then, in your living room or on your phone, the multiverse arrives in a new form: movies, shows, and media that bring these abstract ideas to life. Suddenly, the science that once seemed remote becomes intimate, personal, and entertaining. Think of the Marvel films with their tangled webs of timelines and parallel realities. You watch a character meet an alternate version of themselves, or see worlds collide in spectacular battles, and you feel that same thrill that theoretical physics promises without the equations. You laugh, you gasp, and somewhere in the back of your mind, you realize the story is a reflection of the universe you've been exploring. Marvel didn't invent the multiverse, but it gave it a pulse you could feel. Then there's animation, television, and novels. Shows like Rick and Morty turn quantum branching into humor, chaos, and philosophical reflection. You watch, sometimes amused, sometimes unsettled, as characters leap between realities, confronting versions of themselves they never wanted to meet. And in that absurdity, you recognize something deeper. The multiverse is not just a scientific conjecture, it's a mirror for human curiosity, fear, and longing. Pop culture shapes perception in powerful ways. The multiverse becomes not just a concept to read about in a physics journal, but a story you can live in, even for a few hours. You start thinking in terms of alternate choices and what ifs, replaying moments of your own life in ways both playful and profound. The fictional multiverse blurs the line between science and imagination, making the idea tangible while keeping the wonder intact. But there's a twist here. Entertainment simplifies the science. When the multiverse appears in a movie, it rarely comes with discussions of falsifiability, inflationary theory, or quantum mechanics. The version you see is dramatized, emotional, sometimes chaotic. That can be dangerous if you forget the difference between cinematic multiverse and scientific hypothesis. At the same time, it sparks curiosity. You watch Spider-Man encounter multiple Peters, and you leave the theater thinking, maybe the universe is even stranger than that. And that curiosity fuels discussion. You join debates online, read articles, watch videos explaining the science behind the story. Suddenly, multiverse theories, once confined to the minds of theoretical physicists, become part of everyday conversation. Everyone has an opinion. Everyone has a favorite what if. And in that way, pop culture doesn't just entertain, it educates, or at least inspires a desire to understand. The multiverse craze also taps into nostalgia. You remember earlier stories of parallel worlds, comic book Elseworlds, or old science fiction novels. Seeing these ideas revived on the big screen brings a sense of continuity, a reminder that humanity has always wondered, what else is out there? Pop culture makes the multiverse approachable, relatable, and emotionally resonant, even for people who have never studied a single equation. There's also a communal thrill. You and friends discuss theories, debate plot twists, and speculate wildly about possibilities. The multiverse, once abstract and isolating, becomes a shared experience. You're not alone in imagining that somewhere another version of you took a different path, or that other worlds exist in parallel with your own. Pop culture transforms solitude into collective fascination, and yet there's a subtle tension here. Fictional multiverses often suggest that alternate realities are easy to access, to influence, or to witness. The scientific multiverse is far more distant, perhaps forever beyond reach. Pop culture can inflate expectations, making the public feel as though science is behind the stories. It's important to remember that while the multiverse may exist mathematically, you cannot simply cross into another world, meet another self, or rewrite events at will. Still, that doesn't diminish the emotional and cultural impact. Fiction allows you to explore ethical questions, regret, and the meaning of choice in ways that equations alone cannot. When you see characters meet alternate versions of themselves, you confront your own possibilities, joys, and mistakes. The stories invite reflection, teaching empathy and introspection. Even in documentaries, books, and podcasts, the multiverse becomes a lens for exploration. People use it to ask philosophical questions. What makes you you? What gives a life meaning if infinite variations exist? Pop culture amplifies these questions, turning the abstract into the tangible, the theoretical into the emotionally relatable. And here's the most fascinating part: the multiverse craze loops back to science. Interest generated by films and media can inspire young minds to study physics, to explore mathematics, to dive into cosmology. Curiosity, fueled by entertainment, can evolve into real world knowledge, bridging imagination and rigorous inquiry. You might watch a Marvel film for fun, but it plants seeds that grow into questions about inflation, quantum mechanics, and the origins of everything. So, pop culture does more than dramatize. It humanizes the multiverse, giving faces, stories, and emotions to a concept that could otherwise remain cold and abstract. It teaches you to feel the weight of infinite possibilities, to reflect on your own choices, and to grapple with wonder in ways that pure science sometimes cannot. As you step back from the screen, you notice something subtle. Your imagination has shifted. You look at your life, your regrets, your dreams, and wonder, if alternate versions of me exist, what might they have done differently? What do I still have time to explore? Even if the multiverse is never proven, the ideas it sparks reshape the way you think, the way you feel, and the way you see the universe around you. And in that, pop culture and science converge. One entertains, the other investigates. One inspires emotion, the other demands evidence. Together, they push you to wonder, to question, and to imagine worlds beyond your own. Whether real or fictional, the multiverse has become more than a theory. It is a shared journey, a cultural conversation, and a mirror to human curiosity that stretches from comic books to the edges of the cosmos. After exploring the emotional pull of the multiverse and its dazzling presence in pop culture, you might wonder, where does real science stand? Beyond movies, speculation, and thought experiments, physicists are actively chasing clues, tiny threads of evidence that might one day hint at something larger than our own universe. The quest is subtle, patient, and often invisible to the casual observer, but it is relentless. First, consider gravitational waves. In 2015, humanity detected them for the first time, ripples in space-time produced by the collision of massive objects like black holes. It was a landmark discovery, confirming a key prediction of Einstein's general relativity. But for the multiverse, gravitational waves offer a more speculative promise. If two universes collided in the distant past, they might have left a faint imprint in these ripples, a disturbance not fully explainable by events within our own universe. Physicists scan these waves, hoping for anomalies, tiny hints that reality might be layered in ways we cannot yet fully comprehend. Then there's the cosmic microwave background, the faint afterglow of the Big Bang that permeates the universe. Scientists have mapped it in extraordinary detail, revealing a tapestry of hot and cold spots, subtle ripples that tell the story of our cosmos's birth. Some theorists propose that anomalies in this background could be evidence of bruises from other universes brushing against ours. A cold spot here, a circle there, perhaps a message written in the earliest light of creation. Yet these signals are faint and ambiguous. Every claimed anomaly is debated, dissected, and scrutinized. The cosmos does not yield its secrets easily. Mathematical models provide another avenue. Equations born from quantum mechanics, string theory, and inflationary cosmology suggest that other universes are not only possible, but mathematically natural. These models explore dimensions beyond human perception, structures of space-time that could support entire universes parallel to our own. They give physicists a playground where logic and possibility stretch to the extreme. Yet mathematics alone cannot prove reality. It can guide intuition, suggest scenarios, and inspire experiments. But until observation catches up, these models remain tantalizing blueprints rather than confirmations. And yet, even in the absence of direct proof, the pursuit of these ideas teaches you something profound about science. Real research does not demand instant answers. It tolerates uncertainty, embraces ambiguity, and thrives in patience. Scientists build instruments, analyze data, and refine theories with meticulous care. Each experiment, even if it yields a null result, brings clarity about what the universe is not. And in that, there is progress. High energy particle physics also joins the chase. Experiments at particle accelerators probe fundamental forces in particles, searching for anomalies that might suggest extra dimensions or previously hidden aspects of reality. Every collision, every detection of subatomic behavior might contain subtle hints of realms beyond our own. It's a bit like listening to a symphony in which some instruments are inaudible, yet their vibrations subtly shape the music. Detecting those vibrations could illuminate truths we have never imagined. But the challenges are enormous. You face practical limits. Instruments cannot detect infinitely small signals. The universe has boundaries imposed by light speed and cosmic expansion, and the phenomena sought may be inherently unobservable. Even so, scientists persist. The pursuit itself, this careful, patient labor, reflects the essence of human curiosity, the desire to understand more than what lies immediately in front of you. And here's where the narrative becomes emotional again. You realize that each experiment, each model, each failed attempt is not just data, it's a reflection of human hope. Scientists operate at the edge of comprehension, seeking glimpses of something so vast that it almost defies imagination. That pursuit mirrors the wonder you feel staring at the night sky. It reminds you that discovery is not only about answers, but about the courage to keep asking questions even when the universe seems indifferent. There is also collaboration on a global scale. Teams of researchers from every continent share data, propose models, and debate interpretations. The multiverse, in this sense, becomes a unifying challenge. It transcends borders, languages, and individual ambitions, embodying the collective human desire to push against limits. And in that collective effort, you sense the heartbeat of science itself: curiosity tempered with rigor, creativity disciplined by method. And yet, despite all this effort, uncertainty remains. Every step forward brings new questions. A signal may hint at something extraordinary, only to vanish under closer scrutiny. A model may suggest multiple universes, only to reveal gaps in reasoning. This is not failure, it is the nature of exploring the frontier. You feel the tension, the excitement of possibility, tempered by the knowledge that truth may remain elusive. Even the questions themselves are a kind of reward. They force you to think bigger, to consider scales of space and time that dwarf human comprehension. They challenge you to wonder how reality might extend beyond your senses, beyond your instruments, and even beyond imagination. You feel small, yes, but also part of something unimaginably vast. That paradox, the mix of humility and awe, is precisely what drives researchers forward. And so you understand, cutting-edge science does not need certainty to be meaningful. The act of searching, testing, theorizing, and imagining carries its own value. Even if the multiverse remains unproven, the journey transforms your understanding of the cosmos and your place within it. You begin to see reality not as a fixed stage, but as a puzzle with pieces that may forever elude you. And yet, in the attempt to fit them together, you glimpse something profound about existence itself. In the end, real science is less about confirming fantastical notions instantly and more about stretching the boundaries of what is possible. Gravitational waves, cosmic background studies, particle collisions, and mathematical models are the tools of that stretch. They carry humanity closer to the edge of the unknown, reminding you that even in the absence of proof, wonder and inquiry remain powerful companions. So when you stare at the stars tonight, remember, somewhere scientists are listening, calculating, and imagining alongside you. They are chasing shadows, hints, and vibrations of what might lie beyond our universe. Whether they ever confirm the multiverse or not, their pursuit embodies the very essence of curiosity, the human refusal to accept limits when imagination whispers of something greater.